Right now, we know of 8 planets in our solar system, but for more than a century, scientists have been searching for number 9. It's a proposed super-Earth, a planet past Neptune much larger than our own. Over the years, there's been some evidence that it might exist, and this week, researchers published even more. On Tuesday, scientists announced the discovery of a new, extremely distant object beyond Neptune. It's detailed in a paper submitted to the Astronomical Journal, and it's named 2015 TG387. And while it's not a planet itself, it could point us to the long-theorized Planet 9. The object is pretty tiny, with a diameter of only about 300 kilometers, almost 90% smaller than Pluto's, and it's pretty far out. No, like literally way, way out in the solar system. When it was first observed in 2015 as part of an ongoing survey, it was about 80 astronomical units, or AU, from the Sun. That's 80 times farther from our star than the Earth, or more than twice as far as Pluto is right now. But comparatively speaking, that's actually really close to us. For 99% of its 40,000-year orbit, this object is so far away, we can't even see it. After years of observation, researchers have calculated that at its farthest, it's a whopping 2,300 AU from the Sun, much farther than any other known object. So far, we've only found 2 other objects with orbits comparable to this: the dwarf planet Sedna and the planetoid called 2012 VP-113. These objects are so far out that their orbits are mostly unaffected by the gravity of the 8 known planets. So by studying them, we can learn about the outer solar system and map what's going on out there. And these orbits may already be pointing to something big. All 3 of these objects, including TG387, share similar orbital paths, almost like they're being shepherded by something larger. According to the researchers, that object could be the elusive Planet 9. To learn more, the researchers ran simulations to see how the gravity of a hypothetical Planet 9 would affect the orbits of these objects. And the results were promising. For one, they showed that these objects did maintain stable orbits. In other words, their current paths wouldn't be messed up if a Planet 9 existed out there. The results also confirmed that a hypothetical planet could be shepherding the small objects. That could explain why Sedna and TG387 take similar paths. But to be sure, we need more data, or a direct observation of the planet itself. Scientists are looking, but since estimates suggest Planet 9 would never get closer to the Sun than 200 AU, it's going to be pretty faint and tough to see if it exists at all. Now, even if another planet does exist, don't expect us to send astronauts there anytime soon. Even if we could send a crewed mission that far, research published on Monday suggests we might have trouble surviving the journey. According to the study, which was published in the Proceedings of the National Academy of Sciences, long-term space travel has the potential to seriously damage our GI tract. The GI, or gastrointestinal tract, is the organ system we use to digest food. And this new paper suggests that space travel could make it less effective at absorbing nutrients and could potentially cause tumors. It's all thanks to our good friend, cosmic radiation. Cosmic radiation mostly comes from objects beyond the solar system, and there are a few types of it, including the extra dangerous heavy-ion radiation. It comes from supernova explosions and is made of certain atomic nuclei accelerated to near light speed. Because of its mass, it's much more damaging than gamma and X-rays. Thankfully, our planet's magnetic field blocks most of it, but out in the vastness of space, there's not really anything to shield us against its effects. Previous studies in mice have shown that exposure to heavy ion radiation can lead to damaged brain tissue and accelerated aging during prolonged space trips. And this new paper only adds to the list of potential concerns. In the study, researchers exposed mice to low doses of iron radiation, a form of heavy ion radiation, to simulate the exposure astronauts would receive during a round trip to Mars. Then, these animals were compared to other groups of mice, one which had been exposed to similar amounts of gamma rays, and a control group that received no radiation at all. The goal was to isolate the effects of different types of cosmic rays, and what the team found wasn't that encouraging. The mice exposed to iron radiation developed cancerous polyps in the soft tissues of their GI tracts and had fewer enzymes needed for nutrient absorption. This may have happened if the radiation damaged the DNA in their intestinal walls, making them incapable of normal cell division. Now, it's worth noting that not all mice studies translate perfectly to humans, especially when it comes to radiation. But since we don't have a good way to protect our spacecraft against these kind of rays, it's worth studying them any way we can. Right now, good shielding materials are just too heavy to get into space, and scientists are a long way from making an anti-cosmic radiation medicine. As people get more serious about going to Mars, though, researchers are looking into every possibility. These kinds of studies are good reminders that space exploration is more than just building big rockets. We also need to learn how to take care of the people on board. But someday when we're walking around on Mars, or maybe even Planet 9, it'll all be worth it. Thanks for watching this episode of SciShow Space News. If you'd like to help us make more episodes like this, you can go to patreon.com/SciShow. And to all of our current patrons, thank you. Our team couldn't do it without you.